Unit 5, Lesson 5, and this is Part 2, our second example. I'm going to start by listing the factors of 6, 1 and 6, and 2 and 3. Then, unlike Lesson 4, we do have a leading coefficient other than positive 1. Factors of 4 is 1 and 4, and 2 and 2. You only have to list 2 once. So now I need to list what's called all the possible rational roots. All the possible rational. The word rational just means fractions. So how I can do that is we have plus or minus 1. This list will always go in the numerator. This list will always go in the denominator. And so if we had to list all these out, it could be every one of these values over 1, so plus or minus 1, 2, 3, and 6. There's 8 possibilities, 2, 2, 2, and 2, 8. Then I can put it over 2, so I have 1/2. Well, 2 divided by 1 is simply 2. 3 divided by 1 is 3. Oh, sorry, I did the wrong one. 2 divided by 2 is 1, but we haven't listed 3 halves. We haven't listed 3 halves, and 6 divided by 2 is 3. Okay, then we have 1/4. 2 over 4 is reduced to 1/2. 3 over 4 we have not listed. 6 over 4 is equivalent to 3 halves. So these are all the possible rational roots. 2, 4, 6, 8, 10, 12, 14, 16. I sure hope I don't have to try all 16. I'm going to grab another board, and I'm going to start with 1, -1, 2, -2, and so on. Okay, we have a 3, 2, 1, and 0. There's no missing pieces. X to the third, x to the second, x to the first, and x to the 0. And I'm going to start by testing a 1. Here we go. We drop down, so we multiply, and we add down. We multiply, and we add down. We multiply, and I don't even need to add because I know that's not 0. So I tested 1. 1 does not work. Okay, now I'm going to test -1. Drop down. Multiply, add down. Multiply, add down. Multiply, this does not equal 0. I tested -1. Unfortunately, it doesn't work. I hope I don't get to the point where I'm having to test the fractions. If that's the case, I will grab a calculator to help myself. Let's try 2, because 2 is my next set, 2 and -2. Okay, dropping 4 down. Multiply and add down. Multiply and add down. Multiply, and it works. Wonderful. Now, here's the great part of this. There's only 3 terms left, and so when I get to that point, I know 2 works. 2 is a solution to this polynomial equation. I'm going to write this now just like we learned last lesson, which would be lesson number 4, no x's, 1 x's, and 2 x's. Now, if you feel most comfortable using the quadratic formula to solve, go ahead. I'm going to first see if this is factorable. What multiplies equal -12 and combines to give us 4? 6 and -2, they multiply, and down below they combine. They multiply and they combine to give you a 4. So x plus 6 and x minus 2. And as I said in the previous example, most students then make this big mistake. They forget to look back, and whenever the leading coefficient is anything other than positive 1, you've got to drop the number down below. And then we're going to reduce it. So how do we reduce here? 6 over 4, well, they're both even numbers, so divided by 2 and divided by 2. Again, both even numbers, divided by 2 and divided by 2. And then I like it in this form because I don't have to do any more work. I can see that another answer is -3 halves, and the third solution is going to be positive 1/2. These are our 3 solutions. That means you take any one of these, and if you plug it in for the variable x and complete the math on the left, it will equal 0.